Now, let's talk about our route tables. And we went into it a little bit of detail in the previous one. A route table contains a set of rules which are called routes that are used to determine where network traffic is directed. And each subnet in your VPC must be associated with a route table. Now, the table controls the routing for the subnet, and a subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same route table. Now, we talked about the main route table here before, and all subnets that are not associated with a route table are automatically associated with the main route table. Hence, that's why we have a main route table. So if we don't point other subnets to a separate route table, that's when they'll default to the main route table and whatever routes are associated in there. Let's go ahead and create two additional route tables here, one for private and one for public. I'm going to come back to services, scroll down to my VPC. On our route table, I'm going to click create route table, AWS, public, RT, and associate with the VPC. Great. And then I'll create one for private. All right, now that I have my route tables, let's see if we can actually SSH into one of our instances and see if that works. Now I need the instance IP address or the EIP that's associated with it. So underneath all services, I'm going to drop to EC2, click on my instances. I have my public one. Hey, it's public. I should be able to get to it. I'm going to click connect and grab the information. Now, if you haven't done so already, you're going to notice that it says you must chmod the key and give it enough permissions to be able to utilize it. If you haven't done that, go ahead and do that. I've done that key because I've already utilized my key. All right, let's come to my terminal. Let's expand my terminal so everybody can see here. Clear that. I'm going to paste SSH to it. Why is it not working? All right, let's escape out of this one and take a look at it. All right, now let's update our drawing. We created a public route table. All right, which does have the 10.0.0/16 local in it by default. And then we have a private. All right, let's see what's next. What are we going to do next? There's two things next that we actually have to talk about. One is we have to give our instances a way out from the VPC to the internet. And that's what we're going to talk about is an internet gateway. And an internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. So therefore, it imposes no availability risks or bandwidth constraints on your network traffic. And it serves two purposes. One, it provides a target for your VPC route tables for internet routing traffic and to perform network address translation for instances that have been assigned public IPv4 addresses. So we need an internet gateway. We need a way to get out. But you also notice that we talked about is an updated to your route tables. So the two next things we're going to do is we're going to create an internet gateway, and then we're going to update our route tables to point to that internet gateway in order for us to get out to the internet. So I'm going to come down here to my VPC again. Let's create an internet gateway. All right, now that that's created, you're going to see that it says detach. We're going to attach that to our VPC. All right, it says attach. Now what we need to do is we need to point our subnets all right, to that internet gateway so that it can route the traffic. We're going to update the route tables. This is really where the public and private subnetting difference comes into play. I can point my private subnets to this internet gateway. I can point my public subnets to this internet gateway. Then there's no difference between those subnets. So in order to do that, we're not going to take the private and point it towards that internet gateway. We're only going to update the public ones. So we're going to say routes. We're going to say edit my route. We're going to say anything destined outside. There we go. Is going to go towards the internet gateway. Save my route. Now, one thing that we didn't do here, and I was trying to actually allude to, is that remember, all subnets that are not associated with a specific route table will be associated with the default route table. Well, if we take a look at the default route table, we don't have a route to the internet gateway. So I'm going to associate my public subnets with this route table. Clicking on this guy, I'm going to expand him, say associate. I want this public and this public, and now he's associated with that one. So in theory, we should be able to SSH to our instance. Bam! Works like a charm. Now, let's come back and talk about our private instances. For our private instances to connect to the internet, what we're going to do is put in a network access translation gateway, or a NAT gateway. This is going to allow the private subnet to connect to the internet or other AWS services. So nothing externally or in the public will be able to connect directly to these instances. Typically, you would have like a Bastion host. Well, we've just set up one that we tested and we connected to. So let's go ahead and create one. Now, the NAT gateway sits in the public subnet because it needs to communicate with the internet, and it only has permissions to communicate with the private instances. So I'm just going to put this in the public subnet. I'm going to attach my elastic IP address. If not, you can associate one. Always name your stuff properly. I'll do AWS NAT. All right. We're going to edit our route tables. We're going to take our private ones and we're going to say, hey, you are the only ones that can connect to the NAT gateway. Say that anything destined for 0000, all right, is going to go to my NAT gateway. I'm going to save my route here. Now remember, we didn't associate any subnets with that, so we'll associate the private subnet. All right, looks like we have the private subnets already associated with it. Perfect. Now let's update our board here a little bit on some of the changes that we made. We put in, we'll put a little circle here, this is my IGW. And what this did, check it out, a nifty red marker here, is that it allowed these subnets, we'll just put it right here, there's my instance, to communicate with the internet. Next, I put it right here, so this is another instance, but this is my NAT. And it's allowing, I'll just come out here, these guys that communicate with the internet. And we'll update that drawing. And we have our route table, and we said anything for 0000/0 is going to go to the IGW, and anything for 0000/0 is going to go to the NAT. I guess the only thing left to test here is the private instance connecting to the internet. So how are we going to connect to that? Let's take a look and find out. Now there's two things that I'm going to do before I close this out. One, we're going to try to SSH to our private instance, going to our Bastion host, or the instance we're already on. And then from there, we're going to get to our other host. And then I'm going to show you how I changed the private subnet that's associated with this instance into the public, and then I can actually just SSH into it directly using the elastic IP address. So I'm logged into my instance and I'm going to exit out of here. And if I could type, all right, I'm going to cat my AWS test key. I really don't care that it's on the screen because as soon as I'm done with this recording, I'm going to destroy it. So I've copied my key. We'll clear it out and then we will SSH back into the instance. I will also AWS test key.pem. All right, paste my instance in there. Do not forget to give it a 400 or else you won't be able to get into the instance. Now let's go back and get our IP address of our instance. We'll do this and I'll just open up a new tab. We have our instance. All right, and from there we'll do our private one and we'll click connect. Now realizing that this is the public IP address of the instance, but I'm just going to copy it for the syntax rather than type it really quick. The IP address is 10.0.2.25. So I'm going to come over here, I'm going to paste this, and then I will come to 10.0.2.25. Bam! And it works. Now it's not permission and denied because I didn't sudo SSH. So if I were to actually take this, copy, sudo, drop it down here and say yes, now I can get into my instance. All right, let's exit out of this and then exit out of that instance and we'll do a clear screen. Now, look what happens when we change the route, and actually this is how a public and private route are assigned. If I come here and I edit the association, actually let's see where our private instance is in there. It is associated with the subnet private 1. So let's go ahead and change the association of private subnet 1 in there. All right, and there's private subnet 1. I want to keep that one. We'll change that, and then we'll just add it to a public. So associated routes, which ones are we missing? So I want to put 1 in there, and there I saved 1. Let's come back to our instance, say connect. Should be able to actually get right to it. So, all right. And as you can see, it allows us to get directly to the instance. And this is the only differentiating factor between public and private subnets. All right, everybody, I really hope you enjoyed my quick tutorial on building out the VPC. You can do the same thing with the VPC wizard. I think in the beginning I said I was going to do it. This is already probably about 30 minutes, 20 minutes, a little bit longer than I hoped or anticipated. Hope you really enjoy my drawing here on the board. I think I might go into an artist class. I'm not really sure that. I really appreciate it. I will share this out. Everybody have a good one.